Assalamualaikum warahmatullahi wabarakatuh and good morning. Please let me introduce myself. My name is Nanda Azka Mulia. I am a third student in computer science major in software engineering. My honorable evaluators and my honorable supervisor and the most lovely my honorable friends. First, today I'm gonna explain or I want to presentate about my final year project 1. It's about neural network and accuracy testing of software quality assurance. So it's prepared by me and my supervisor is Professor Dr. Habibullah bin Harun. First of all, I want to acknowledge and first most I would like to thank my supervisor Professor Dr. Habibullah bin Harun, whose expertise was invaluable in developing the research questions and methodology. Your insightful feedback pushed me to sharpen my thinking and evaluate my work. So today's presentation overview, there will be 5 parts. First of all, I will explain about the introduction, the problem background, and secondly, the literature review, and thirdly, the methodology, and fourth, the plan development algorithm, the fifth, the conclusion. Okay, let's get started. So in this introduction, I want to tell everybody about the problem background. So according on my research and before I want to determine this kind of topic about the software quality testing in using neural network is because the World Quality Report says 59% of the respondents stated that had project in place or plan to use AI for quality assurance. So I will explain more detail and specific on the next slide. So based on this program background and I'm a computer science student which already study about computational intelligence, which we study about AI or we say artificial intelligence, and we already study about software quality assurance. I have an idea what about if we combine using a machine learning based system that can really more easier than the traditional QA quality assurance testing or people say it as manually. So next slide, I will explain about the research aim and the objective. So there's 3 things that I want to say. First of all, to identify the parameters. What kind of parameters that affect the accuracy of the development time? So the time span. What kind of select testing method between the traditional and artificial intelligence of software quality assurance we must choose by fast. So secondly is to apply the neural network, which is the ANN, or people say artificial neural network in the software quality assurance for the testing. Thirdly, to analyze the accuracy of the debugging software using neural network and traditional software quality assurance. So there will be a comparisons. For the research scope, firstly, it will be a comparing the traditional software QA and testing with the machine learning based software QA testing with the effectiveness time, cost, and the development quality. So we're talking about the accuracy about the data that we're gonna use or we're gonna test. So secondly is about the project will conduct with different type of result from machine learning based software quality assurance testing and traditional software testing. Okay, I'm gonna explain about the literature review. So there is 5 questions in my slide. So how's the accuracy testing and what kind of benefit we can get, you know? So what is automated software quality assurance testing? Software quality testing is something we needed when we want to try or to test something we develop. We want to see where is the error, where's the incorrectness, how many percent is the correctness. So QA is a subset of the software development life cycle, or we say SDLC. And QA automation means is using automated testing tools to run tests on the software being developed and report the result. Can we use artificial neural network? Of course. There's a computational intelligence. We can use this by using anything. And neural network is like a human being. You know, you can think normally, and we can get the accuracy of the logic of a human being. So, what is traditional or manual software quality testing? So the difference is like manual testing is a deal of assessing the user experience, the UX, we call it, and the look and the feel of an application which only can be done by human is the most often used newly designed test cases and on the ad hoc basis for the test cases changeable requirements and automating testing runs on the frameworks creating using machine learning based tools and is generally more accurate than the manual testing especially in a regression testing, which can become tedious for manual testing. So that's the main important thing. What is QA? What is artificial intelligence? Can we combine them? The answer is yes. I will explain more specifically. So this is the parameters in determining the accuracy of software quality assurance using AI. We want to see the comparison between the academy, the integrity, the documentation, the usability, the maintainability, the efficiency, the understandability, and the correctness of the validity and the testability. This is the main point. So I just will explain some of it. Like for example, the academy. If we use manual testing, it will cost many money, and efficiency will spend a lot of time. But when we try to use an automated or we're using an AAN or artificial intelligence for the testing, it will be a great thing, and it will be more specifically in the time. And for the correctness or the accuracy, it will be more higher than the manually because there will be a human error. But by system, it will also be a system error, but a system it will be conducted by a human being which already think and controlled by it. And the understandability of the system is much more complicated. Complexity it will be understand because when we try to use a big data or a huge capacity of it, it will be recorded. But if using manual, it will be hard, and the integrity of the data will be much more safer in the system, and also the documentation will be much more be recorded. I didn't say the manual will not be that bad, but by the system it will be safe. And by means safe is not only by safety but also safe by the memory. And the usability is more efficiency. And the validity is more higher. The testability we can try. We can see how is the output of the accuracy, the incorrectness and the correctness. The maintainability of the system is much more easier than a human thinking because we need time, we need some more effort about it. Okay, this is the methodology of the framework. How does the artificial intelligence neural network gonna be? So there's a number of important stages in the automated QA testing process, which typically runs in parallel with the software development or the SDLC. So first of all, the first one, we must do a data preparation. We input the data, we identify the parameter. After that, we can define and format the network, input and the target, and fast to divide the data into presets, which is going to be the training data, which is going to be the test data, and after that we can get the validation. In this validation, we can create the next step for pass 3. We can create the feed-forward back propagation in 3 network layers. It will be an input layer and a hidden layer, so will be the output layer for the output of the answers. After we can get the output layer, we can train the network, test the program. Is it correctly based on the system? For example, the system say 100% works. Okay, let's test this program. Is it 100%ly works based on the comparison tool or the machine learning based that we already use? So and that you can see the decision about the output correctness. Is it false or is it true? That's the methodology of the framework, how the ANN or the artificial neural network works. So this is the analysis that I was using the example of the data set for the development. So as we see, there's an age, job, marital, education, default, housing, loan, contact, month, day of week, duration, and campaign and paydays. So this is the type of the type data is the integer, and the attribute is the all. This is the input. Imagine if we try to use a manual testing based on this a lot of data, it will be spent time of lot of time and spend time of lot of effort and sweat. So much spending time. But by using a system, we just input the data. We just use the raw data, just input the data, just wait for a minute or for a second, and it will be outputted. And we can get the decision correctness or the incorrectness. So this is the analysis, how we plan the development algorithm that I'm going to explain. This is the flowchart of the neural network. With the previous one is the framework, much more specifically what is inside, but this is the outside of the flowchart, based on talking about how the neural network is going to be working. So first of all, we can start. We can do the data preparation and input the processes, pre-processes data set, and we can create the ANN, artificial neural network, initialize the weight and the bias randomly and reach the maximum iteration. So we can see if it's reached the maximum iteration, it will say yes and will continue to test the ANN with the test data and display the confusion matrix and the error graph, and that's the end. But if it doesn't have a maximum iteration, it will say no and will continue and will try. The system will try by default and randomly select one training data set and forward pass input through the hidden layers to the output layer and calculate the store error and then back propagation error to the hidden layers, which gonna calculate about it and adjust weights of the hidden layer output layers. That's how the flowchart neural network works. So neural network have three: input layer, hidden layer, and output layer. And there will be an example and explanation about it in the next slide. Okay, this is the example of the output of the artificial neural network for the development that we already see the previous data. So as you see, there's the previous data so much, the data type, the integer, the input. So based on this, I use a hidden layer. So the green one is the input layer, and the middle one with the red dots is the hidden layer, and the yellow one is the output layer. So the output layer is only like yes, no, or like 1 and 0. So what is the effectiveness of the hidden layer? It's based on the data capacity. It's based on the company or the researcher or the studies that want to see what's the difference. In here we can try to solve an error, but in manual testing data we cannot have another references, but using system we can have a new references. For example, in here I use 5 hidden layer and 10 hidden layer and 15 hidden layer. So it will be like, for example, the input will be more easier, and the secondly, why I use 10 and 15, it will be more complexity data. It will be based on how they can manage to select the data, how they can put in A, B, C. It's much more easier and much more concrete about the data, and we can have a nice conclusion about the decision incorrectness and correctness. So this is the analysis, the summary. Based on the instance or the data is the total is like 4,119. Imagine if you use manual or the traditional way, but by system we can get a number, an input output which is really accurate. As we see in here, the accuracy is about 92% and the incorrectly 7%. And this is a fact of data. We can have the data set really in front of our face. We cannot imagine, or we can just suggest, like a manual or tradition, like we can count again. I guess we can use this iteration or we can use this weight, and we can just think of a suggestion which is not really concrete and you cannot determine 100%. And so in the confusion matrix, as we see, A is yes and B is no. And this is the divided data, which will become the incorrect or the incorrectly percentage. Okay, the conclusion that I want to say is like a neural network can be implemented in quality assurance testing performance. It's really good. Identify parameters that affect the accuracy of the development time and time spent. Select testing can be managed, and the determinant of the accuracy of correctness and incorrectness with a good value of outcome. That's the most important thing. We want to see the outcome. What kind of outcome it gonna be. In every try and testing error, we want to see of course we want to study the fail and error. But the benefit of using automated is like testing is a great way to save your company time and money by spending by speeding, I mean, so sorry, the testing process and delivering a higher level of accuracy. It also frees up the QA team for more advanced testing, enables you to spend test coverage, leading to better quality products because of the accuracy of it. And automation won't do absolutely everything for you. You still have to pick the right tools and plan and create the maintain test. So it's on your choice. But we as a human and a computer science student, we already create call an artificial intelligence which can help our lifestyle, environment, and for the sustainability development for the future. I guess that's us. That's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.